Have you ever noticed how large language models are just, well, they seem to be everywhere now.
Yeah,
They're
absolutely.
popping up in everyday business operations. And sometimes, we might not even realize it.
Hmm.
Maybe you've used a customer service bot or perhaps an internal tool that summarizes documents. Chances are an LLM is powering it.
Right.
But getting these models to be truly reliable, really enterprise-ready, that seems to be where the real challenge often lies, doesn't it?
It really does. It's one thing to have a cool demo, quite another to bet your business process on it.
Exactly. So today we're going to do a deep dive into this strategic approach to LLM prompt engineering. We're focusing specifically on how this works in an enterprise environment, something like Snowflake.
Hmm.
And we've got some really insightful source material to guide us through this. It outlines a pretty comprehensive strategy.
That's right. For this deep dive, we've really dug into a detailed document. It lays out a robust strategy for managing LLM prompts, at scale. Our mission today really is to unearth those critical insights, the practical steps you actually need to build, govern, and importantly, scale your LLM applications effectively.
Right.
We're trying to move way beyond just like talking to a chatbot here.
Yeah.
This deep dive should give you a shortcut to understanding not just the how, but maybe more importantly, the why behind integrating these LLM solutions robustly into your business.
Okay, let's unpack this then. When we talk about LLMs, the term prompt is absolutely foundational. So at its core, what exactly is an LLM prompt? How should we think about it?
Yeah, good place to start. Think of an LLM prompt as like a finely tuned instruction manual for the AI.
Okay.
It's the structured input text you give to the large language model, could be GPT, Claude, or models integrated right into a platform like Snowflake.
Right.
And it's designed specifically to guide it toward a very specific desired output. It's really about giving the LLM these structured parameters, almost like programming it, but using natural language.
Okay, programming with words. I like that.
Exactly. And a typical prompt isn't just like a simple sentence. It usually has several key parts.
Ah, okay. What are those?
So first, there's the context. This kind of sets the stage. It tells the LLM what role to play or what scenario it's in. Something like, you are a strict support ticket classifier.
Got it. Sets the persona.
Precisely. Then you give it the direct instruction, like classify this ticket. Pretty straightforward.
Mm-hmm.
Next is the actual input data you want it to process, the text itself, like user cannot reset password.
Okay.
And finally, you often include a format expectation. This makes sure the output is structured exactly how you need it. Maybe something like respond with, bug, feature, or request.
So you get predictable output.
Exactly. Each piece helps the LLM understand precisely what you want it to do and, just as importantly, how you want the answer formatted.
That breakdown really clarifies the building blocks. It's more involved than just asking a question. So, knowing that, how do these prompts evolve for, more complex tasks? What are the main types of prompts we see, and when would you use one over the other?
Yeah, the source material highlights three main types, and they sort of build on each other in terms of sophistication.
Okay.
The simplest is zero-shot prompting. This is where you give the LLM a direct instruction without any prior examples.
Just ask it directly.
Right. It's quick, simple, kind of context-agnostic, good for generic tasks. An example might just be, classify this, user can't log in.
Okay, pretty basic.
Yeah, like asking someone a question they should just know the answer to.
Right.
The next level up is few-shot prompting. This adds a significant layer of reliability because you give the LLM a few examples of input-output pairs before the actual task.
Like showing it the pattern first.
Exactly. This is super useful for more nuanced classification or when you need the LLM to follow a very specific pattern or style.
Makes sense.
So you might prompt it like, example 1, cannot log in a bug. Example 2, need export your request, now classify, user can't log in.
Gotcha. Like showing a couple of solved puzzles.
Perfect analogy. Then, for the really complex stuff, we move to chain of prompts, sometimes called multi-step reasoning.
Okay, chain of prompts. Sounds interesting.
Yeah, this is where you break down a big, complex task into a series of smaller, sequential prompts. Each step builds on the last.
Modular.
Exactly. Highly modular, which makes it incredibly traceable, auditable, very important for enterprise.
I can see that.
Imagine that support ticket classifier again. Instead of one giant prompt you might have, step 1, identify intent from ticket text. Then, step 2, use that intent to classify severity. And maybe even an optional step 3, validate the intent and severity logic.
So each step feeds the next one.
Precisely. It builds up to a comprehensive solution. It's like guiding someone through a complex process, one clear instruction at a time, making sure they get each part right before moving on.
That chain of prompts example really clicks. But it does sound like it could get pretty complex to manage if you don't have the right setup.
Oh, absolutely.
So how do these different types, especially as you go from zero-shot up to chain prompts, how do they really enable those more sophisticated interactions, going beyond just simple Q&A into
Yeah.
these guided processes?
Well, what's really fascinating is how this progression lets us kind of imbue the LLM with a sense of, well, reasoning might be too strong a word, but logical processing.
Okay.
Zero shot is direct, right? Ask and answer.
Mm-hmm.
Few shot introduces pattern recognition, getting it to adhere to examples.
Right.
But chain of prompts, that's where you're actually orchestrating the LLM. You're getting it to perform logical operations, break down a problem, maybe verify intermediate results, make decisions based on those results.
So it's not just answering, it's participating in a workflow.
Exactly. It shifts the LLM from being just an answer generator to being a participant in a multi-stage analytical process. And that's absolutely crucial for those business-critical tasks where you need reliability, you need explainability.
That makes a lot of sense.
Now, once you grasp these building blocks and, their increasing complexity, the absolutely crucial next step in an enterprise setting is figuring out how to store these prompt templates centrally.
Ah, okay. Not just having them scattered around.
Definitely not. This is really foundational if you want to manage prompts in a scalable, enterprise-ready way, moving beyond just having them, buried in different code bases or sitting in individual text files somewhere.
That makes perfect sense. Storing them in a table feels like a big step up from treating them like disposable code snippets. What's the biggest hidden benefit you've seen when organizations actually do this? And maybe what's the immediate pain if they don't?
Oh, great question. Because it really gets to the strategic value. The biggest hidden benefit is probably rapid iteration and experimentation without breaking things.
Ah, safety.
Yes, when prompts are just hard-coded, changing one means a whole code deployment cycle, right? Testing, potential disruption.
Right, a whole process.
But with a centralized table, you can update a prompt, test a new version, even roll back instantly if it doesn't work well, and you have a clear audit trail of all those changes.
Okay, much more agile.
Exactly. Now, if an organization doesn't do this, the immediate pitfalls are pretty clear. You get inconsistent LLM behavior across different apps using slightly different hard-coded prompts.
Nightmare.
Total nightmare. You can't easily track which prompt version actually produced a specific output, which makes debugging incredibly hard if, say, a production LLM starts acting weirdly.
Okay, so centralization is key. What are the other main advantages?
Well, beyond that rapid iteration, the benefits are substantial. Obviously, centralization itself, everything's in one auditable place, which simplifies maintenance hugely. Then there's versioning. Just like software code, prompts evolve. Storing them in a table lets you track those changes, update them without breaking production flows, and even A/B test different versions.
Like V1.0, V1.
Exactly. Then you get separation of logic and data. Your application code stays much cleaner because the prompt logic isn't hard-coded in it.
Good practice.
And it provides explicit chained workflow support, those multi-step prompts we talked about. You can store each step as a separate row, making them really easy to retrieve and assemble dynamically.
Okay, so tell me more about that table. What would it look like?
So imagine a table, maybe called prompt templates. It wouldn't just hold the raw prompt text. It would have a templated as a unique key.
Right.
A use case said to link it to a specific business function like ticket classification.
Okay.
The prompt type, zero shot, few shot, chain step 1, chain step 2.
Got it.
The prompt text itself, of course. And crucially, a version tag like v1.0, v1.1 few shot, v1.2 chain.
That version tag seems critical.
It's absolutely essential for governance. So you could have an insert statement for a simple zero-shot prompt like, classify this ticket as bug, feature, or request, tagged as v1.0. For a few shot, the prompt text would include those example pairs, and it might be tagged v1.1 few shot.
Okay.
And for a chained prompt, you'd have separate rows, maybe one for step 1, identify the user intent in, and another for step 2, given the intent is classify severity, maybe both tagged under a v1.2 chain concept. This structure makes them super manageable and accessible.
That setup for prompt templates really does seem to streamline things. But okay, LLMs need dynamic input, right? They need to work with new, specific details each time. How do you feed in that live, real-time data without having to rewrite the whole prompt every single time?
Yeah, that's where replacing placeholder variables comes into play.
Okay.
Think of it kind of like mail merge in a word processor. You design the main template once.
Right, with the fields.
Exactly. Then you just slot in the specific names and addresses for each letter. In your prompt templates, you use clearly marked placeholder text. Typically, you see double curly braces like ticket or maybe user role.
Okay, like template variables.
Precisely. Then, when it's time to actually call the LLM, your application code dynamically inserts the real input data, maybe the ticket text from a user's actual support query, or their user role from their logged in session right into that template.
How does it do the inserting?
Usually just with a simple string replace function,
Yeah.
you swap out the placeholder, like ticket, with the actual content of the ticket.
Yeah.
And what's really powerful, especially in those multi-step chains we discussed, is that the output of one step, say, an extracted intent or a generated summary, can become the dynamic input for the next step's placeholder.
Ah, so the chain builds on itself dynamically.
Exactly. The workflow can intelligently build on the previous results as it goes.
Okay, so the prompt is assembled, placeholders filled.
Yeah.
What does it actually look like to send it off to the LLM and get that response back, especially in an enterprise system? How does that handshake happen?
Right. So in an enterprise setting, particularly within a data platform context like Snowflake, you're typically invoking the LLM using an external function.
An external function. Okay.
Our source material mentions one conceptually called extclm. Think of this external function as a secure, managed gateway to your chosen LLM service, whether it's running inside or outside your platform.
So it controls the access.
Precisely. It handles the authentication, the API call, maybe some basic error handling. Let's walk through a quick conceptual flow for that multi-step chain prompt example, drawing from the source.
Okay, yeah, let's do that.
You might start with step 1, extract intent. Your code fetches the template, replaces ticket with the actual message, say, app not responding when saving data, and sends this full prompt via extLM. The LLM processes it and returns, let's say, the intent, bug.
Okay.
Then your application takes that result, bug, fetches the template for step 2, classifies severity, replaces its placeholder intent with bug, and maybe adds the original ticket text too. The prompt might become, given the issue is classified as bug, rate severity, low, medium, high for this ticket, app not responding. Call ext calls again.
Right.
The LLM returns, maybe high. And optionally, that high severity could trigger step 3, suggestion or action plan. Fetch the template, insert bug and high, maybe the ticket text again. Suggest next action for a bug with high severity regarding app not responding. Call the function one last time.
Got it. So each step informs the next through these controlled calls.
Exactly. It allows for this really nuanced, sequential decision-making, all orchestrated cleanly through these external function calls. It becomes a genuine, automated workflow.
We're clearly talking about building some powerful, intelligent applications here.
Yeah.
But, with great power.
Comes great responsibility. Yep.
Exactly. How do we make sure these things are actually working as expected? And maybe even more importantly, how do we keep track of what happened, especially if something goes wrong or the LLM gives a weird answer? Auditability seems key.
Absolutely, Kay. And this brings us right to the necessity of creating a logging table. You simply have to log this stuff.
Okay, log everything.
Pretty much. Logging the prompt that was sent and the response that came back is vital for auditability, for monitoring performance, and crucially, for debugging when things go sideways.
Makes sense. What goes in that log table?
The source outlines a promptee logs table structure designed for this. It would capture details like the use case SAID and the prompt type to categorize the interaction.
Okay.
The actual prompt text that was constructed and sent to the LLM,
Right.
the LLM response that was received back, and really importantly, things like a success flag. Did the call complete without error? And maybe an error message column for capturing issues.
Ah, good for diagnostics.
Definitely. And if you're using those chained prompts, you can log each individual step's prompt and response, maybe linking them with a transaction ID. This gives you complete end-to-end traceability for even the most complex workflows.
Wow. Okay.
So if an LLM does go off the rails, you know exactly which prompt, which inputs, and which step in a chain led to that unexpected behavior. That's absolutely invaluable for enterprise use cases. You can't fix what you can't see.
That level of logging sounds incredibly powerful for figuring out what happened.
But once you've logged all those responses, what's the next step? How do you actually measure if your prompts are, doing a good job? How do you quantify their effectiveness, their accuracy?
Right. Logging tells you what happened, but evaluation tells you if it was good. To measure accuracy, you need to compare what the LLM predicted against what the correct answer should have been.
The ground truth.
Exactly. So this usually involves two key data sets. You need your ground truth data. This is your set examples that have been manually labeled or represent a gold standard answer.
Okay.
And then you have your LLM predictions, which are the outputs you logged from the LLM in your prompt logs table.
Right. Compare the two.
You simply compare them.
Yeah.
The source material details how you can calculate overall accuracy. For instance, you could write SQL queries to count how many times the LLM's identified intent matched the ground truth intent.
Okay.
Or you could get more specific. Count how many times both the intent and the severity classification were correct, right? Measure different aspects.
Absolutely. You can even perform more granular evaluation, looking at accuracy by intent type or assessing the accuracy of individual steps in a chain, like how accurate was step 1 intent detection versus step 2 severity classification.
Find the weak links in the chain.
Precisely. And once you identify areas where the accuracy isn't meeting your threshold, the feedback loop is actually quite direct. You can manually retune your prompts by simply updating the prompt text in your prompt templates table for that specific step or use case.
Ah, so you tweak the template based on the evaluation.
Exactly. Update the template, maybe bump the version number, deploy it, and measure again. There's also mention of potentially using Snowpark evaluation logic, maybe in Python, for more advanced automated tuning or A/B testing of different prompt versions against your ground truth.
Okay, that makes sense. But accuracy is one thing. What about behavior? How do we ensure the LLM behaves exactly the way we need it to, especially in sensitive areas like finance or healthcare, or just where the output format needs to be super consistent? We need control, right? Predictability.
Yes, absolutely. Beyond just getting the right answer, controlling the way the LLM responds is critical. This is where adding system prompts or guardrails becomes absolutely essential.
System prompts, guardrails.
Okay. Think of a system prompt as a kind of pre-instruction or a meta prompt that you prepend to the user's actual input or the task-specific prompt. It's designed specifically to influence the LLM's overall behavior, its tone, its scope, its constraints.
Like setting the rules of engagement beforehand.
Exactly. It's like telling the AI, okay, before you even look at the user's question, here are the fundamental rules you must follow for this interaction.
What are they typically used for?
Several key things. You can use them for a direct behavioral instruction, like respond only with one-word category names.
Right, forcing a format.
Yeah, or for persona setup. You are a strict, impartial classifier used by a regulated healthcare system, setting that tone and role, and very commonly for scope limiting. Only classify incoming requests into one of these three categories: bug, feature, or request. Do not provide explanations.
Drawing boundaries.
Precisely. Our source actually gives some fantastic real-life examples of these guardrails in action.
Oh, yeah. Like what?
Well, for an HR chatbot, a critical guardrail might be something like, you are an HR assistant. You are strictly prohibited from providing legal or medical advice.
Crucial.
Absolutely. For a medical ticket classifier processing patient notes, a prompt could mandate: only classify using official ICD-10 codes. Respond solely with the code and its corresponding label. No additional text.
Very specific output needed there.
Totally. Or for a finance assistant dealing with market data, do not speculate or make predictions. If specific data required for analysis is missing from the input, respond only with the phrase insufficient data.
Prevents hallucination or guessing.
Exactly. And maybe one more for like security vulnerability scoring. Analyze the vulnerability description. Avoid using subjective or ambiguous language like seems or might. Classify the severity only as low, medium, or high, and provide a brief, factual justification referencing the input.
Wow, those are really practical.
Yeah. They help force predictable, often easily parsable content. And in a multi-step chain, they can even be used to verify coherence between steps, ensuring the LLM's output stays aligned with your enterprise needs, your compliance requirements, everything. They're really your first line of defense for responsible AI implementation.
It really sounds like these prompts, especially with templates and guardrails, are becoming almost like code themselves, or at least a critical piece of application logic.
That's a great way to think about it. They embody the business logic for the AI interaction.
So, if prompts are like code, how do we manage them over their life cycle? What happens when you need to change a prompt that's running in production? Or maybe roll back to an older version if a new one isn't performing well?
You've hit on another absolutely critical point for enterprise adoption: This brings us squarely to versioning and review.
Okay, versioning for prompts.
Yes. Just like you manage source code in software development or models in MLOps, applying version control principles to your prompts is vital for proper governance.
Makes sense. What are the benefits?
It gives you complete auditability. You always know exactly which version of a prompt generated a specific response. Super important for compliance and debugging.
Right.
It ensures repeatability. You can precisely rerun or retest a specific prompt version during updates or for validation. It provides rollback safety. If a newly deployed prompt version unexpectedly reduces accuracy or causes problematic behavior, you can easily and quickly revert to a previously known good version.
Essential for production stability.
Absolutely. It also enables multi-version runs. You could, for instance, run v1.1 and v1.2 of a prompt in parallel for A/B testing to see which performs better against live data before fully committing.
Oh, interesting. Like canary testing for prompts.
Kind of, yeah. And importantly, it provides chain-level tracking. You version not only individual prompt steps, but also the definition of the entire chained workflow itself, giving you comprehensive control over tuning and governance.
So how is this tracked? Another table?
Oh, likely, yes. The source conceptually mentions a prompt versions table, or perhaps adding version tags directly to the prompt templates table, like we discussed. The key is tracking those changes systematically with meaningful version tags v1.0, v1.1 few shot, v1.2 chain, maybe v1.2.1 fix. This brings true software engineering discipline to managing your LLM logic.
This level of control, versioning, auditing, it's incredibly important in a business context, which naturally leads to another question. Access control. In any enterprise system, you can't have everyone having access to everything. How do you control who can actually run these LLM prompts? Or maybe more importantly, who can modify these critical prompt templates? Security and compliance must be huge here.
Huge, absolutely paramount. This is exactly where role-based prompt execution, or RBAC, role-based access control, comes into play.
RBAC for prompts, okay?
Yep. It's all about ensuring secure, auditable operations by strictly controlling who can invoke the LLM calls and, crucially, protecting those prompt templates and the resulting logs from unauthorized viewing or tampering.
So how do you enforce that?
It's typically enforced in several layers, using the platform's standard security features. First, you control secure external function usage.
Right, that ext column thing.
Exactly. You would grant the usage privilege on that specific external function only to specific authorized roles. Maybe you create a dedicated analyst's role or an LLM map service role for applications. This prevents just anyone from making potentially costly or unmonitored calls to the underlying LLM.
Okay, gatekeeping the LLM call itself.
Right. Second, you need secure prompt template access. For most users or roles that just use the prompts, you'd grant only read-only select access on your prompt templates table.
So they can read the template to use it.
But they can't insert, update, or delete rows.
Right.
Only specific admin roles, maybe a prompt engineer role, would have modification privileges. This protects the core logic.
Got it. Protect the templates.
Third, secure prompt logs. For the prompt logs S table, you'd likely allow the application or user roles to insert new log entries as prompts are executed.
Right, they need to write the logs.
But you would strictly prevent, update, or delete permissions on that table for almost everyone. Once a log entry is written, it should be immutable to maintain that critical audit trail.
Makes sense. Immutable logs.
And finally, maybe the most robust approach, especially for complex chains, enforce prompt execution via stored procedures.
Wrap it all in a procedure.
Exactly. This is often considered a best practice. Instead of allowing users or applications to construct and run arbitrary sequences of LLM calls, you encapsulate the approved logic fetching templates, replacing placeholders, calling the external function, handling intermediate steps, logging all within a stored procedure, maybe called something like run chained prompt.
Okay.
Then you grant execute permission on that stored procedure to the authorized roles, rather than giving them direct access to the underlying tables or functions.
So they can only run the pre-approved controlled workflow.
Precisely. It prevents misuse, ensures consistency, enforces the guardrails, and makes the whole process much more secure and auditable, regardless of who or what application is triggering the LLM logic.
Okay, so you've done all this amazing work. You've meticulously engineered the prompts, put in robust guardrails, established strong governance with versioning and RBAC. Now, how do you actually use all this intelligence in a real application?
Right.
How does this connect out to the broader software world outside of just running queries in a database environment.
Right, that's the critical final piece making it useful. This is where something like the Snowpark API comes in, acting as the bridge.
Snowpark, okay. The
Yeah.
interface for code.
Exactly. It connects all that carefully engineered prompt logic, the templates, the versioning, the data residing within Snowflake, to your actual production-grade LLM-powered applications.
Like what kind of application?
Think real-time ticket classification systems, sophisticated chatbot assistants integrated into your website, or internal tools, dynamic knowledge extraction tools that analyze documents and populate databases, things that directly power business workflows.
Okay. How does Snowpark help there?
Well, Snowpark, particularly Snowpark for Python, lets your application code running wherever your app runs make programmatic calls back into Snowflake to execute those stored procedures or functions that run the LLM logic.
So the app calls a procedure.
Right. It allows for dynamic context injection your application can pass in real-time data streams or user session info to populate those prompt placeholders. And importantly, it facilitates that complex multi-step reasoning with branching logic within your application code. Your Python app can call step 1, get the result, then based on that result, decide whether to call step 2A or step 2B, fetch the appropriate template, and continue the chain.
So the application orchestrates the chain based on the results.
Exactly. The value delivered here is pretty immense. You can embed this governed LLM logic directly into standard web apps. Think things built with Flask, Django, FastAPI.
Right, common frameworks.
It enables true real-time classification and response generation because the calls can be fast. It ensures full MLOps compatibility. You can integrate LLM outputs alongside traditional ML model results or maybe vector search results within the same application flow.
Okay.
It supports that sophisticated multi-step reasoning where the application handles the branching. And critically, it brings prompt governance into your application code because your app can be coded to specifically request, say, v1.3 of a prompt template from the prompt templates table, ensuring consistency and auditability from the application layer right back to the data platform.
Can you give a quick example of that branching logic?
Sure. Imagine that ticket classification app again. Your Python code calls the procedure to get the intent and severity. If the return severity is high, your Python code might then trigger a completely different workflow, maybe call it function, to create an urgent alert in PagerDuty.
Yeah.
But if the severity is low or medium, it might just call another function to log the ticket in a standard queue for the next available agent. That decision, that branching, happens in the application code, orchestrated via Snowpark based on the governed LLM output. That's real decision automation.
That really ties it all together.
Yeah.
Okay, let's do a quick recap then. What are the core strategic benefits we've really pulled out from this deep dive into enterprise prompt engineering?
Yeah, let's summarize the core best practices and their benefits. First, absolutely use prompt templates with versioning. That's key for reuse, consistency, and managing change over time.
Right. Templates and versions.
Second, always sanitize your dynamic input meticulously. You've got to prevent prompt injection vulnerabilities or just malformed strings from breaking your LLM calls. Security first.
Good point. Sanitize inputs.
Third, it's really non-negotiable. Log the prompt sent, the responses received, and the prompt version used. This gives you that essential traceability, auditability, and is invaluable for debugging.
Log everything. Know the version.
Fourth, leverage chaining prompts with logic branches. This is how you tackle complex, real-world decision trees and enable that multi-step reasoning that goes beyond simple Q&A.
Build workflows.
Exactly. And finally, fifth, strictly limit access via RBAC roles. Enforce secure execution, protect your templates, protect your logs, treat your prompts with the same security rigor as sensitive data or source code.
Okay, great summary. So, looking at those practices, what are the overarching benefits? What does this whole strategic approach really give an organization?
The overall benefits are actually pretty transformative when you implement this properly in an enterprise context. You get what you could call zero-code intelligence.
Zero-code intelligence.
Yeah, meaning you don't necessarily need traditional ML model training cycles just to change the AI's behavior. Sometimes, just changing a few words in a version prompt template can instantly update your application's logic.
Ah, fast updates.
Super fast.
Yeah.
This enables composable logic through those chained prompts, allowing for transparent, step-by-step reasoning that you can actually follow.
Right, transparency.
You gain precise behavior shaping. You can set the LLM's tone, enforce rules, define its persona just by updating text in a template, again, without costly model retraining,
Control the behavior.
which leads to incredibly rapid iteration. A small tweak to a prompt, deployed safely via versioning, can instantly change how your LLM application thinks or responds, letting you adapt super quickly to new business needs or user feedback.
Agility.
Huge agility. It's inherently more explainable and auditable because the prompts themselves are transparent, they're versioned, they can be reviewed by humans. You achieve task-specific tuning very efficiently, adapting a powerful general LLM to your unique business logic just through clever prompting.
Tailoring it.
Yep. There's seamless dynamic data injection, feeding that live contextual information right into your templates from your applications or data platform.
Real-time context.
And critically, the whole system becomes governable and secure with controlled version, role-restricted access, bringing this powerful AI capability firmly within your enterprise's existing security and compliance frameworks.
It sounds like the LLM app becomes less of a black box.
Exactly. It's not a static deployment you hope works. It becomes a living, breathing component of your system that you can observe, understand, fine-tune almost in real time, responding to new market conditions or refining its performance without massive overhead.
Wow.
Yeah, this whole exercise, it really goes way beyond just, crafting a few clever prompts. It's fundamentally about laying a robust foundation for governed, auditable, and genuinely intelligent decision automation right within your enterprise environment.
Right, it's the whole system.
It's the system. Through structured prompt versioning, through role-based execution controls, through intelligent chain reasoning pipelines, we've basically outlined how you can transform a data platform from just storing data to becoming a kind of living thinking system.
A living thinking system.
One that adapts to context, learns implicitly from how you tune its behavior via prompts, and crucially, remains fully observable and under control. What we're really talking about here is a strategic leap forward. It's about making AI truly governable, making it reusable, making it scalable, all while aligning it perfectly with core enterprise principles like security, auditability, and tangible value creation.
That's a powerful vision. So listening to all this, with this deeper understanding now of structured prompt engineering and seeing how it brings intelligence, yes, but also governance and this rapid iteration capability right to your data, here's a thought to leave you with. What new intelligent decision automation could you now envision building within your own sphere? How could you start transforming your data platform into that truly living thinking system?